developing a compact nuclear reactor for future Mars habitats. A power hiccup on Earth is probably little more than an annoyance, but it could be deadly during a theoretical deep space or Mars mission. NASA is looking into ways to power life support and scientific instruments reliably during future manned spaceflights, and small-scale nuclear reactors are at the top of the list. The space agency is working with the U.S. Department of Energy and the National Nuclear Security Administration to test such a system. It's called KRUSTY, Kilopower Reactor using Stirling technology, and it's being ramped up to full power in a few weeks. According to NASA engineers who spoke at the recent National Atomic Testing Museum in Las Vegas, the Kilipower Project began testing the current reactor iteration in November 2017. It's a small-scale reactor designed to produce power in the 110 kilowatt range, as the name implies. 1 kilowatt is about what you'd need to power a toaster or a few laptops, and the test design should reliably produce that much. That's not enough to power an entire Mars habitat, though. NASA estimates you would need 40 to 50 kilowatts of power, so it may send several small KRUSTY devices if it cannot develop a single reactor that can reach the necessary power levels. The KRUSTY rover, by comparison, uses about 200 watts, 0.2 kilowatts. The system is between 5 and 6 feet tall, but the uranium-235 nuclear fission core is about the size of a paper towel roll. Heat from the reactor is distributed by a series of sodium heat pipes. The heat generates power via a high-efficiency Stirling engine, which drives a mechanical flywheel and piston via the repeated expansion of gases. By coupling the engine to an alternator, the system produces power. A small nuclear reactor might sound like overkill, but it has all the properties necessary for powering a human habitat on another planet. They produce a lot of power relative to their size and weight, and they're highly reliable. Solar panels are bulkier and don't work as well on Mars as they do on Earth. Other types of generators would require too much fuel to be economical. In a 2012 test, a similar reactor topped out at 24 watts, so a great deal of process has been made. We'll know for certain how efficient the new reactor design is this March when researchers conduct a full power test. If the KRUSTY design produces sufficient power, it could become the basis for future Mars reactors.